Well, this is John Black, Super Chemist, here in part 3 of how to make, nitrocellulose ester polymer. Most people call it gun cotton, or nitrocellulose, or flash paper, if you're a magician. Now, there is an easier way to make nitrocellulose. Okay, you don't have to have nitric acid. You can have potassium nitrate, and I have a video about how to get that. You can just buy that at Lowe's. It's already pure. But you can actually make the nitric acid in situ. And the way we made our nitric acid, if you watch my video or anyone else's video or already know, you do what you do when you make any acid. You take the salt of the acid you want, and you drip a stronger acid on it. So you would get sulfuric acid and drip it on the potassium nitrate. You'd have nitric acid. So you can bypass having nitric acid by just using the potassium nitrate. You're already mixing it with sulfuric acid and make it in situ. Okay, but and if you want, I can, if you want to see the process or whatever, because I'm not doing a video on it. That's why I did it on here. And that's another thing I wanted to say is, the one thing in the first video, I was like, this is how they do it in a real lab. When I said that, I didn't mean that my process and the way I'm doing in my video is the way they do it in a lab. What I meant was most videos out there, and if you want to watch them, just let me know, and I'll give you the computer address for it. You can jump over and watch them. But what I meant is all the videos out there that are making nitrocellulose are making the nitric acid in situ. And in a laboratory or, in an industry, you wouldn't make it in situ like that. You would have the nitric acid and react it and make your nitronium ions that way. You know what I mean? You wouldn't make you wouldn't make it in situ like that. That's all I meant. I didn't mean that the rest of my procedure or anything else I'm doing is the way they would do it in a lab. There's nothing the way I'm doing it is the way the way they would be doing it in the lab. Okay, I'm cutting corners all over the place here. And I'm doing a lot of guesswork. So I just wanted to say that and bring that up. This part 3 is just going to be about me talking about my mistakes in the first 2 videos and my expertise or whatever, knowledge about explosives and stuff like that. Like the disclaimers and like I said, mistakes in the last 2 videos. And then the next video I'll do all the finish the experiment. I was going to put it at the end of this one, but I figured this one is almost 12 minutes of just me talking, so I figured I'd just split them up that way they're split up. I wanted to go over it. Obviously I wanted to do the disclaimer, do this at your own risk. This is not an educational, not a instructional video. It's just a vlog or a blog of me doing experiments. So do it at your own risk. I do not have a degree, alright, in chemistry. I don't have a degree in anything. I barely have a high school diploma. I didn't drop out, but you might as well say I did drop out halfway through 11th grade because I stopped going pretty much. I've never studied explosives. I've never read anything about explosives. I've never read anything really about nitrocellulose, or I've never read any, or studied anything about any of this stuff. Okay. Chemistry, yeah. Explosives, no. Number 3, and that's what brings me to number 4, right? Is that I may not be covering every safety concern that needs to be covered. So if you duplicate the video and you don't do it exactly the way I'm doing it, or you miss something, or I miss telling you something, something bad could happen is all I'm saying. All the experiments I do are just guessing. There's only one experiment that I've done so far that I actually had the instructions sitting in front of my face, and that was how to make carboxy methylbenzene. which is basically another name for it is toluic acid. I had the instructions for that, and even when I had the instructions, I still didn't follow them, 100%. So just keep that in mind. Most of my experiments, basically, I have, the equation. That's it. I mean, I have a lot of chemistry knowledge too, but and experience in making some stuff. But it's not like I, have some kind of instruction booklet telling me how to do stuff. I have no instruction booklet. I've never read a lab book in my life. I've never read any kind of lab techniques book or anything like that. I mean, I've read, probably about 30 chemistry books, but none of them on the lab aspect of it. You know what I mean? None of them. No safety stuff, no nothing. Okay? So keep that in mind. Experiment 6, safest procedure. In video 1, I say I'm talking about the safest procedure that some guy came up with, where he does a 1-to-1 ratio. Or he does because before this, they was doing a 1-to-1 ratio, and before that, they weren't even doing that. They were, but anyways, he came up with this thing of do 2-to-1 ratio between the sulfuric acid and the nitric acid, right? When I bring that up, I'm just saying that ratio there, I don't know the ratio of the cotton. I don't know stoichiometry of the cotton. I know the equation. I don't know what the safest ratio, though, is, because, the equation is 1 mole of nitric acid and a catalyst of sulfuric acid, but he's saying, no, use 2 moles of sulfuric acid and 1 mole of nitric acid. So the equation and the stoichiometry could be different, you know what I mean? And I've never read anything about the cotton stoichiometry. I have no clue, okay? All I was saying, and that right there, all I did was get it out of Wikipedia. If you go to Wikipedia, you can read that paragraph that I'm talking about. And it's about that guy who came up with this, that ratio of the acids. Same with nitrating twice, okay? I've never read that in a book in my life. It's going back to the when I'm talking about that in the video. I'm saying before this, people used, like I'm talking about back in the 1800s. That's why I still had my mindset in the 1800s. You know what I'm saying? So going back, so having the mindset of talking to someone in the 1800s, early 1800s. They weren't using enough nitronium ions. You know what I mean? They'd have like a 1/10 of a mole of nitronium ions and 10 moles of cotton. Obviously, it's not going to nitrate 10 moles with 1 mole, right? And that's the reasoning. And then they went up to the 1-to-1. They started doing, you know what I mean? Learning that, well, you need to nitrate it more. And that's why I was saying nitrating twice, because when I learned about this 20 years ago, a guy told me how you should nitrate it twice. But I've never read that in a book. He wasn't a chemist either. He was just a home chemist like me, although he did know about explosives. But, that's something back in, I'm talking 100 years ago, nitrating twice. They probably, just like I did, add in extra nitronium ions, you know what I mean, so that you can get everything nitrated or whatever. I don't know, though. That's the whole point. I don't know. I do know that if you are going to try to nitrate something and you don't use enough nitronium ions, you're going to have to nitrate it twice, or you're going to have nitrocellulose that's unstable, okay? Number 8, in the one video, I say that I nitrated for 24 hours. I put it in text because I forgot to say it. So I just put a window in there and the text comes up saying, oh, I actually did it for 48. I did not do it for 24. That was a typo. I don't know why I did that. You can nitrate for 24 to 48 hours. That is, I've read that in books. But it's best to do for 48. 48 is the best. I said stoichiometry of the cotton. I do not know. I've never read. All I have is the same equation you got that I showed at the beginning of, the experiment. Washing and storing. I've never read anything about how to wash it, how to store it, except what's in Wikipedia. And I know from past experience about storing, not that I've ever stored it, but when I was talking to people back in the day about it, they would tell me about the storing, that you cannot store it. You need to store it under some kind of liquid, water, believe it or not, alcohol. I wouldn't store something that can catch on fire in alcohol, but whatever. Otherwise, and I went over this in one of the videos, if you store it wrong, that's one of the main concerns. I think it's actually a law. Back in the mid-1800s, they already knew you got to store it under water, store it under some liquid, or you will have a chance. Even if you washed it correctly, you still have a chance of it spontaneously igniting. And last but not least, number 11. Is this an explosive? Okay, I do say it is an explosive in one of the videos, and as a buddy of mine on BitChute, and he's a smart guy, he caught it right away, that it was a falsehood. Technically, like he said, it's not an explosive. It is a accelerant. It's an accelerant, but it can be used as an explosive. You know what I mean? If you have it confined to something, then it becomes explosive. You know what I mean? So technically, it is not an explosive, but I don't want people to repeat the videos. The deal, okay? So saying it's because it does explode if it is confined, it is an explosive, but technically it's not. I don't think it's not labeled as an explosive, is what he's saying. So I just wanted to put that in there, since he is right. It is not an explosive technically, but can be used as an explosive. So anyways, let's get to the washing and the whatever. In the last video, I washed it a couple times. I'm still washing it. Keep in mind, I'm not washing it correctly. As I said in the one video, the guy who did it the safest way, one of the things he changed was he made everyone wash it 8 times. Okay? And I don't know what that means. Does that mean, you put it in water for 48 hours and then put it in, each time you put it in water and then baking soda water? Or is it just baking soda water? I don't know. You know what I mean? I definitely do. I'm not washing it 8 times, that's for sure. So I'm definitely not doing that correctly, okay? I always remember, science is great.